Hi, I'm an old guy and I do maths. Today we're in the business of finding an axis of symmetry and a turning point. And we're dealing in the realms of quadratics and parabolas. And I've got a sample quadratic down here, x squared plus 4x plus 3. And I'm just going to go through the various ways in which we can find the turning point and or the axis of symmetry for the graph that this generates. So let's start with factorizing. If we factorize this thing, what we get is x and 3 and 1. And these are both positive. And that tells me that the x-intercepts are at -3 and -1. And so halfway between those 2 points, we get x equals -2, which is the equation of the axis of symmetry. Now, in order to get the turning point, what we would do is we would put that -2 into either this form of the equation or this form, and we would get a result for the y coordinate. Now, when we do this exercise using turning point form, we're going to get that coordinate anyway, so just bear with me. The second thing that we could do, and it's helpful when you have a quadratic that is much more awkward than this, something that's very hard to, very hard to factorize. You can use this formula, -b over 2a. Now, the a, b, and c in this, you don't see c here because it's unnecessary, but b is that number, and a is implied here as 1. So it is -4, b, over 2 times 1, which is -2. That gives us the y coordinate of the turning point of this, and also by implication where the axis of symmetry cuts through the x-axis. Okay, turning point form. Now this takes a little bit more space, and we'll just use this plus 4x plus 3. Now, what I'm going to do is I'm going to move this into turning point form. So to do that, I start by what looks like completing the square. Okay, so what I've done here is I've halved that and squared it. And because I've added this to this equation, I take it off here. And what I wind up with is x squared plus 4x plus 2, or rather 4, let's put it that way, like that, plus 3 minus 2 squared, -1. If I factorize this, what I get is I get x plus 2 all squared minus 1. And this is now in turning point form, and this tells me the turning point, which is -2, -1. So I refer you back up to here where I got -2 on both occasions. And I said at this point that we would wait till we had turning point form to discover what the y coordinate would be, but we would get this y coordinate simply by putting -2 into this. Now, so that's turning point form. and that's a fairly easy job sometimes. Not always, but sometimes. So what I'm focusing on here is a range of solutions to this problem, and your job would be to choose the easy one. Now, calculus. For those of you who know how to differentiate, this will be pretty straightforward. For those of you who don't, maybe stick to the first three until you get to calculus. This is not really a lesson in differentiation, so I'm going to differentiate this thing, which means performing an operation upon this this function here and turning it into a different function. And what I'm going to do is I'm going to make this differentiated function here, 2x plus 4 equals 0. And so 2x is equal to negative 4, x is equal to negative 4 on 2, x is equal to negative 2, and we're back in the business of popping that into this equation to see what the other coordinate is. There you are. A range of methods for finding an axis of symmetry or a turning point on a quadratic or a parabola if you have the graph and it shows its coordinates. Thanks very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.